shows that almost the same size of the regions are mapped with new technology like AUVs. But still, most of the ocean is not mapped yet. So we should rank the priority for mapping the ocean when considering the need for the ocean map. In general, ocean ridges, endangered reefs, and oil and gas regions are considered the most important regions that need the map of the ocean. First, ocean ridges is the hill of the ocean that needs an ocean map. Mapping the ocean ridges is important since we can monitor the movement of the Earth so that we can monitor the disasters like tsunamis. Second, we should map the endangered coral reef region since we can understand of biodiversity and we can check the health of the coral reef. In these days, it is really important to sustain the environment for future generations. So it is also important to map these regions. Last, we should monitor natural resources like oil or gases by mapping the ocean. We can find potential resource deposits with this map. So these three regions that I mentioned before, that I mentioned in the previous slides, are locations that have high priority for mapping. Trajectory is also important when using AUVs. We should consider the current of the sea because it can slow down the AUVs or speed up the AUVs. So we should minimize the resistance by the sea current and maximize the energy efficiency by considering the sea current. For example, sea currents range from 0.1 meter per sec to 0.8 meter per sec according to the region like this. And its region has its own current direction. So when you're operating AUVs, the current of that region should be also considered first. So here is a rough calculation about the spread of AUVs. When you suppose two AUVs can cover 1 kilometers, it takes 4 years to map the whole ocean ridges with 100 AUVs. And for coral reefs and oil and gas fields, it takes about 4 months with 16 AUVs. So it is really crucial to develop a new technology to map the ocean with high speed. And another important issue in AUVs is the energy source of the AUVs. In general, battery, fuel cells, and solar power are widely used in AUVs. For batteries, it can operate few hours to couple of days. It has high energy density, but it has environmental risks, and it should be charged regularly. With fuel cells, it can operate several days to a few weeks. It also has high energy density and eco-friendly because it discharges only water as a byproduct. But the fuel cell systems are complex and very expensive. Also, since the hydrogen storage is limited, it should be regularly recharged. With solar power, there is no definite operation time. It can only be operated with sufficient sunlight. It is eco-friendly and can be operated with a low cost. But the power output is low and the dependency on weather and time is its limitation. For the final presentation, we are planning to actually simulate the mapping of the AUVs. We think of simulation, ocean current, and the trajectory of AUVs on this current. And we will calculate optimal number of AUVs or the time to map the whole region with this new method. And here's references. And thank you for listening.
Thank you. Question from other team members? No. Yay.
Thank you.
I have one. This is TA of the class, and I have one question and comment.
Speak up, please. Mike, please.
So you mentioned that there are three types of energy sources, which are batteries, fuel cell, and solar panels. And
Yeah.
in case of fuel cell, you mentioned that the hydrogen is the main source of the power, but when the device is in underwater, you should consider that how to get also oxygen, not only hydrogen. So please check the point. And I have one question. Which power sources are you are considering to get on your device for simulation?
For the first question, as you mentioned, I think fuel cells cannot be used in the underwater vehicles. Rather than I think AUVs like floating on the water, the fuel cell can only be used in this type of vehicles. And what is the second question again?
But what is there any concept of energy sources you are planning to get on your simulation or target system?
Um,
What types of energy you are considering?
I think we consider various types of energy sources like batteries or solar powers, but I think we are gonna mainly focus on the solar power system because solar power system with sufficient sunlight, because it is very hard to consider the usage time of the batteries or fuel cells. So we will just focus on the solar powers with sufficient sunlight to simplify the problem.
Okay, thank you for this.
You too.
So you mentioned in the future plans that you're going to do simulation.
Yep.
And tell me what's the simulation tool that you are planning to use.
We also consider a lot of various types of simulation tools like ANSYS or MATLABs, but I think the MATLAB will be simple to use and simulate the current, I think, but we will try both methods.
That's it for me.
All right. My comment is that question. Do you remember the comments coming from your proposal presentation time?
Sorry?
There has been a comments when there was a proposal.
Ah, I didn't consider that comment.
You should check with that previous comments first, and then answer to the audience that what did you do about that comment, right?
Yep.
All right, and then for me, it is still something like a proposal stage. Too broad, your status of project is still broad. It looks like a proposal.
Yeah.
So I recommend you to focus further down to a specific problem rather than to solve all the problem.
Okay.
All right. Thank you.
Thank you.
Then we go on to team 5. Who is speaking? Team 5.
Okay. Hello, I'm Sokran, second presenter of Team 5. Our team's term project is improvement of small target detection for maritime extent. So let's begin with a brief review of our first presentation. Our project goal is to improve the abilities to detect direct seafarers near the coast by using a data-driven approach, specifically deep learning. So we anticipate three main challenges: insufficient amount of trained data, low quality of real data, and small target problem. So in the first presentation, we conceptualize our project topic and outline the entire schedule. This is our entire project schedule, and we are currently in the second stage. Until the second presentation, our main focus has been on collecting data to train the deep learning algorithm. The presentation will follow this structure. Firstly, an introduction to the deep learning process. Then I will cover the three main topics we have addressed. Finally, we will conclude and discuss our future plans. These figures provide an overview of the deep learning algorithm. The model is trained, and the AI model is trained using training data, and its performance is evaluated with test data. As mentioned earlier, we have identified three main challenges, and our focus in this second presentation is on challenge 1 and challenge 2. Moving forward, I will detail the progress in data collection. The data set consists of two types of images: RGB images for daytime and IR images for nighttime. Obtaining numerous real RGB and IR images of maritime extents poses a challenge. So instead, we can utilize the synthetic data set generated solely by computers. Two images shown in here are examples of highly realistic 3D game images. We can obtain images of maritime extents in various situations, including day and night, rain, fog, and snow, from a commercial 3D game like GTA or Battlegrounds by utilizing scenario rendering. These images can show complex or dangerous situations that are challenging to capture in real-life scenarios. By utilizing data from various situations, we can train the AI model to more accurately simulate real maritime extents with sufficient data. This is an example of scenario rendering, demonstrating changes in time and rain conditions. Next, we will move on to data verification. As mentioned, since the synthetic data is not real, it needs to be verified to ensure its conformity for training the AI model. We check whether the existing deep learning model trained with the actual data set is recognized in the 3D game. We use a YOLO algorithm. You only look once, a popular object detection deep learning algorithm. As a result, with the trained deep learning model, this YOLO algorithm confirms that object recognition works in a 3D game, like in this image. So we can prove the conformity of our synthetic data for training the deep learning model. Up to this point, we have discussed challenge 1, and now we will shift our focus to challenge 2, real data pre-processing. In real maritime extents like rain and fog can lead to a decrease in image quality. So these low quality images of camera can be an obstacle to detecting people in the sea, even if the AI model has been well trained. So this is an example of low quality real image. So we need to pre-process the image before inputting it into the AI model. There are many image processing methods to improve the quality of low quality images. Here is an example of an image processing method. And this picture is one of the example, CLAHE, contrast limited adaptive histogram equalization, which enhance the visibility of details in the image. We will apply this method to real image to achieve the high accuracy in object detection. Next, we will proceed with the conclusion and summary of the presentation. Firstly, we generate a sufficient and diverse data set using the 3D game engine and scenario rendering. Next, we verify the synthetic data set for AI model training. Finally, addressing the challenge of lower quality real images, we explored image processing method to enhance image quality. Lastly, we will present our future plans. Until the final presentation, we will explore the optimal image processing method, which is suitable for our situation. And we will then construct the deep learning model for small target detection. And following that, we plan to train and evaluate the AI model. And additionally, we will work on dimensioning the shape and determining the camera location. This outlines our job location plan. And it is the end of our presentation. Thank you for your attention.
Question from other team members? Yes. Speak louder.
How much time or how many hours do you get the data?
We didn't training yet, but I think it would be take 6 or 7 hours.
7 hours.
Yeah.
Thanks a lot.
Other question? Oh, TA.
I have two questions. I am very interested that your presentation topic and how to solve the lack of real image data. So you told that you're going to solve that problem with game engine data. So I am very curious that the model that made by the game engine data can really detect the real accident situation. So in next presentation, the reliability of the model should be solved in the presentation. I have one more question. What tool are you going to make AI model, such as MATLAB or Python?
It may be Python code.
So, comment, I like that you had your goals clearly defined and they were certainly achievable during the time. And I like that you use games to gain images to make your friends possible. And one thing that I can share is that maybe you can make your PC more visible and keep your conversion job.
Good to see the answering to previous comments. First time. About your presentation style, I don't like such a presentation style. I don't have a next chance to present again, but not read narration and also speak up. Otherwise, audience do not listening to your presentation. About the image, synthetic image, similar to TA's question, I don't like to do either. So consider to use film or documentary. That may be better to use instead of synthetic image.
We consider that.
All right. Thank you very much. In 6.
위에 여기 있어. Right. 6가 여기서부터 좋은가?
네. Hello, I'm Heng Shin, the second presenter of Team 6. I will present about underwater construction. Before the start of our midterm presentation, let's review the proposal presentation. Increasing interest in underwater travel and rising sea levels due to climate change have made underwater habitat essential. So we decided to design underwater structure for Korea. Since underwater is more complex than above water, there are several important considerations to take into account. First one is structural defect, second one is energy supply, and third one is ground stability. Today's presentation will focus on searching design, and we will finalize the design approach. The contents are follows. For underwater construction, we will focus on 2 points. First one is construction method and second is materials. Typical underwater construction method includes caisson, cofferdams, and driven piles, and offsite building and float and lowering. Actually, all of these underwater construction methods have same underlying goal: avoid building in underwater. Instead, make water avoided in various ways or settle the structures that have already been made on upper water. Although offsite building and floating and lowering method is simple, but too expensive compared with other methods, so we will compare the other methods. First, caisson is process of assembling a large box structure, stabilizing it into the sea, and constructing is conducted inside of the box. To drain water inside the box, it controls air pressure. It is principle of caisson method. When you put the cup in the water enters the cup until air pressure and water pressure becomes equal. So put the air pressure into the cup to balance air and water pressure at the bottom. From this process, air pressure causes high pressure at the bottom. It can cause it, it can cause seepage and soil instability, so it needs a sophisticated techniques, and it is best for only for bad luck. Second one is cofferdam. Cofferdam make temporary enclosure around the structure site to create drying working space, and installing the large wall and pump inside the cofferdam to drain water. Then work area is dry, and after the construction is carried out, the cofferdam is removed to obtain the finished structure. Since pitted wall is exposed to water, it must be reinforced to prevent erosion. And most important, collapse of cofferdam into the construction site could be occurred during construction, and it is extremely dangerous. It is cofferdam. It makes dry area by temporary enclosure. Third one is driven piles. Is vertical steel column hammered into the soil or rock to construct frame of building. It allows construct sturdy structure without removing water, like Cation or cofferdam mentioned earlier. However, it is more suitable to overwater structure like Apple's Marina Bay store. It is Apple's partial submerged Marina Bay store, which is made by driven pile method. This is pros and cons of each method. Each method should be determined by seabed condition. Therefore, we will discuss the construction method again after deciding on the seabed in Korea in final presentation. So second consideration is materials. When building in water, materials must be used that can instance a variety of complications, including water pressure, corrosion, and erosion. The most common material used in underwater construction is concrete, steel, and acrylic glass. We will discuss about details for each materials. Concrete is composition material composed of aggregate bonded together with fluid cement that cures over time, and it is different properties different based on ingredient named cement. A special variety of concrete underwater is able to set quickly despite water currents and fares well in salty water. Concrete is used through following process. Compacting and curing is important to use concrete for underwater structures. In curing and compacting process, it would be evident that there is certain setting time which causes the poured concrete to settle down to solidified pieces. When constructing underwater, it would not be possible for concrete to be kept still, as there could be currents that follow with the water. Although we use special construction method, long settle time is big disadvantage. Hence, a concrete mixer that has faster setting time than normal must be chosen. After the setting, it has direct relation to setting time, as a faster concrete does not have a freedom to disperse. So in addition, most construction work would be involved some sort of anti-dispersion agent in mixer or time. There are many types of concrete, depending on cement, which has different ingredient and its mixing ratio. But among them, PPC is suitable in underwater construction since it is better resistance to surface attacks and setting times is lower than OPC. And next, we will discuss about steel. Steel is alloy of iron and carbon with improved strength and fracture resistance. Especially, steel is typically enclosed by concrete, formed a strong structure for underwater buildings. It has different types of steel depending on ratio of iron and carbon and additional metal components. Stainless, galvanized, carbon, alloy steel are suitable for marine use. Stainless steel contains molybdenum, which helps resist the corrosive effect of salt water. The higher percent of molybdenum is the better. They are corrosion resistant and can both machine and weld. However, it is weldable, but process is not easy as the other welds. And so it is not much suitable for our underwater structures. Galvanized steel is created by coating the base material with zinc. This zinc coating protects against corrosion caused by elements such as water or extreme temperature. The thickness of zinc coating depends on application, but general ranges from 0.5 miles to 20 miles. Galvanized steel can be used anywhere since its protective layer helps prevent rusting even in moist environment. And carbon steel is alloy of iron, carbon, and the other elements like silicon. Its high strength to weight ratio makes it greater for multiple uses. Carbon steel is also resistant to corrosion, but it can rust if exposed to moisture. It prevents by using a sealant on it, but it is not much stable for our structure. Alloy steel is steel type containing more than one alloying element. Whenever you add each element, often introduces new characteristics or improves certain material properties. Generally, a basic steel has iron content and a small percentage of carbon. Cadmium is the common alloying element that manufacturers add to other elements to enhance corrosion resistance and properties. In general, zinc varies in price depending on the thickness of zinc, but it is always more expensive than alloy steel. So considering price and pros and cons, we will use alloy steel rather than galvanized steel. And the next, acrylic glass is, since it is transparent, and so acrylic glass is used for underwater windows such as aquarium and submarines. Acrylic glass and glass looks very similar, but there are some differences. Acrylic glass has higher impact resistance than glass. It is also 10 times more shatter resistant than glass, and it is more transparent visible light. Also, acrylic glass is weight approximately 50% less than glass. The lightweight of acrylic also helps improve the ease of installation and environmental efficiencies. Although acrylic is softer than glass, it can be scratched more easily. And the price of acrylic is more expensive than glass. Although glass is have some more advantages for price and maintenance since less scratch, but glass cannot be used because it is likely to rupture and corrosion in underwater. So we must use acrylic glass. Next, we will consider the energy sources. We will analyze the cost and advantages and disadvantages of each energy sources. The cost mentioned the next slide is value considering the initial installation cost. There are several challenges of transporting electricity to offshore sites. First one is transmitting electricity over sea often involves long cable length and leading increased power losses over extended distances. Second one is technological challenges. Transmitting electricity over the sea requires dealing with the unique condition, the marine environment. Considerations include the durability of underwater structure, corrosion, and the impact of natural elements such as wave and currents. And since transmitting over sea can be more expensive compared to land, also installing cable underwater can impact the environment. So it would be either if we get energy from the marine environment. Typically, there are solar power, wind energy, tidal current energy, and wave energy. So we will study which each energy source is most appropriate to use. The figure is about change of effectiveness of solar and wind by country based on global weight average LCOE. Even this improvement was surpassed by that solar PV. The renewable power sources was 710% more expensive than the cheapest fossil-free solution in 2010. However, driven by spectacular decline in cost, it cost 29% less than cheapest fossil-free solution in 2022. Over the same period for offshore wind energy, wind went from being 258% more expensive, but it decreased as just 17% more expensive when 2022. From the graph above, we can see that using offshore wind power generation and the solar energy as energy source for underwater construction is no less economical than fossil fuels. Also, you can see in the table, solar energy power generation is lower as cost from $0.445 per kilowatt hour to $0.049 per kilowatt hour. Also, for offshore wind is also lower as cost from 0.197 to 0.081. For the tidal current energy, tidal power generation is still an energy source undergoing technological development. And in the case of Ultramuk tidal current in Korea, the power generation goes high at 401 per kilowatt hour. In global standard, it is $0.5 per kilowatt hour. This analyzed as a result of high cost of equipment and the construction due to growth stage of tidal current power generation technologies, and the economic feasibility of scale has not been yet applied. And for the wave conversion energy, wave power is emerging energy technology in early stage of development, making speculating on cost difficult. Wave energy systems have potential to be as cheap as $0.70 per kilowatt to build, but will depend on location and maintenance cost. However, at the moment, the cost of wave power are generally very high because they are in research phase of development and generally paid by government grants or research grants.
How many slides you are left?
Almost finished. Yeah. And the industry is expected to grow, but it remains challenging to implement wave energy generator at an unusual scale. And also maintenance for these plants is projected to be very expensive because they will be submerged in constantly moving salt water, because constant movement can lead to more breaking. And wave energy plants will most likely need regular and costly maintenance. This table is pros and cons of each energy sources. As a result, tidal energy and wave conversion is not sufficient to supply electricity to our building, and it is expensive. So we will use offshore wind power and also solar power. To summary, we will finalize the design constellation except construction method, since it is depending on the ground stability. So it is our finalized design. And the last part is future plans. For the final presentation, we will research the suitable seabed in Korea and considering ground stability and economic effect. And then we will estimate the feasibility of design. It includes load estimation of an investment and consideration of some regulation. Thank you for attention.
Question from other members. Oh, TA.
That's very maybe perspective. And I'm wondering, it is underwater case, so the pressure of the water is very significant. So have you ever considered the pressure in the calculation?
We didn't calculate the pressure, but these materials are usually used in the underwater structure made. So we just it is fit to hydrostatic pressure.
Thank you.
So maybe so now we have some concrete research about the topic. So I suggested to more the chemical parts and finalize.
Right. Previous comments did not answer yet. You're still reading the narration. See, it is only 10 minutes presentation, right? You can memorize 10 minutes of presentation. English. So you don't need to read. If it can be a 1 hour, you cannot memorize. It's only 10 minutes. Next time, right?
Yes.
And I saw too much details today. Still, you need to fixing or deciding which type, which is size, what is the economy, something like that at this moment. Not material, not putting method. That can be the detailed design stage. So why you are choose the fixing type? You said economy says fixing type is better than floating type. But I saw that in Seoul, Hangang River, 세빛둥둥섬, it is floating type, even though there is a very shallow water there. So you need to say, you need to check the economy between two skies.
Yes.
Also, I could not see what is your collaboration between members of your team. I cannot see any collaboration results.
Collaboration.
Collaboration among team members. You have a job assignment.
Yeah.
I cannot see those collaboration. Did you really collaborate each other or not?
We are job allocation. Like
I know, but I cannot see what your other members are doing on this. You should show me that you did collaboration so that this result is coming from out of this collaboration. Next time.
yes.
Final one is there is another team working on habitat, underwater habitat. You can combine those ideas to your project. Maybe two teams can collaborate. I don't know. All right. Thank you very much. Good.
Hello, I'm Sang Lee of Team 7. Our team member is me and Yunshik and Nicholas. Let's start. You may forget the content of the proposal, so I will briefly remind the motivation. As sea level are rising rapidly as global warming accelerates, so in not distant future, many areas will be underwater. There are several ways to deal with this sea level rise. One of the solution is the floating island. Sorry. So looking at the sketch of the floating island, as shown in this figure, you can see that many of the sketch are planning for the island as low density housing. Low density housing is take up a large space, but only a few people can live there. So we thought that if a floating city to be a solution to sea level rise, it needs to be able to accommodate many people. So in this project, we want to design a high-rise floating building. So with this project, we will figure out how it should be designed and whether it is economical. After the proposal presentation, we found out what factor needs to be considered for when designing a floating structure, and we find out the existing structure and analyze how they were built and how they were designed. And lastly, we discussed about the challenge of the high-rise floating structure and what is the advantage and disadvantage of the floating high-rise. To design a floating structure, we need to know the mechanics of the floating structure. First, you can easily imagine that there is a 6 degrees of freedom are defined in the floating structure. And as you know, to achieve the floating equilibrium, gravity force and buoyancy force must be balanced. And as shown in this figure, the position of the center of the gravity force and buoyancy force is determine the static stability and restoring moment. And as I told before, there is 6 degrees of freedom, so we have to solve the 6 equation of motion. And when it comes to the external force, a floating structure is under hydrostatic pressure and wave loadings. And there are two main types of the structure for the floating structure. One is a pontoon type, the other is a semi-submersible. In the pontoon type, the structure is floating, and static stability is more important than dynamic. In the semi-submersible type, some part of the lower structure is submerged underwater, and dynamic stability is more important than static. In the pontoon type, there are floating body and the momentum at the mooring facility and the excess load and the breakwater. And there are several types of the mooring system for pontoon, such as a dolphin method and chain cable method and pier wall method and tension leg method as shown in this figure. And lastly, where a floating structure will be installed is also important part. That determines which type should be used, and wind condition such as the speed and direction determine the specification of the structure. And unlike other floating structure, the floating building is where people live, so accessibility to the city is also important part. So when considering the accessibility to the city, installing near a city would be a good option. As the next step, we found out the existing structure and analyzed them. There are several references. The first figure is the float at Marina Bay, and second is, as you know, that heavy floating island in Han River, and third one is the hotel Haegungang. Interestingly, this floating hotel is opened in 1988 and moved to Vienna, and later on it moved to the North Korea. And first is a sketch of the oceanic Busan. Let's take a closer look at the float at Marina Bay. There are four main components. One is a mooring system, floating body system, and connecting system, and access bridge. The dimension of the floating body is 14 meter and 16 meter by 1.2 meter. And this structure is constructed with the weld milestone. The weld milestone is have a high tensile strength and elasticity, so it can withstand a heavy load. And there is a connecting system that ensures sufficient strength and rigid connection to the floating platform when the pontoons are interlocked. But this structure can disassemble and be configured. And there is a different mooring system that needs to be studied for our floating ship, like a conventional mooring system involving the cable and chains, and heavy frame, guide dolphin, and cast-iron pipe. Because our floating structure, it needs to be moored to permit the vertical movement of the structure to follow the sea level rise. So in this float Marina Bay project, they choose to use the dolphin mooring system of 6 piles, but these dolphins are designed to be detachable just over the seabed to allow the clear water surface for ship sporting activity in the bay. Lastly, we discussed what are the challenges of the highlight floating structure. When the way we see it, for the highlight floating structure, there are several challenges. One is first they require a lot of the structure for the supporting, and as this is the highlight structure, there is an additional device for the evacuation, and also it cannot ignore the effects of wind. And as the floating structure, the collision also should be considered and prepare for disaster such as the storm and tsunami also needed. And we discussed the pros and cons of this structure. High-rise floating building can be solution to sea level rise and take up less space, but there are several disadvantages. First is ball factor should be considered in design, and there needs more supporting structure, and it is hard to maintain the structure. Now we are going to set the requirement for the floating building and build a simple theoretical model, and then finally we will estimate the final cost. Well, thank you for listening.
From other team members. No. GA.
I have a comment. Presentation. I think the final concept of your team should be selected and present view of the presentation until the final presentation.
As we are trying to decide which type, so we will decide soon.
participant pre-existing the investigation pre-existing person, which is how you can study this, and then it's got a PA comment. I think you should now do more about this big your result. And one question is that how are you going to feel
The theoretical model. So there's several mechanics characteristics. So we first consider primary consideration is the floating equilibrium and the stability, and then we should consider other connecting system or boring system like this. So we will first build a simplified mathematical model using this, and then we choose which type is appropriate for our structure.
All right. Why not fixed type? Comparing to team 6, they are saying fixed type is economical and floating. But you already choose a floating type.
This also it may be better because but we aim to suggest concept design that highlight floating building because there's a few try of this highlight floating building sketch, so it may be meaningful to suggest a new type of the building.
Well, if it is not good for economically, then it cannot materialize in later stage.
Yeah,
right?
so we will test the economic whether it's feasibility or not.
So you need to, can I say, negotiate with team 6.
Yeah,
Otherwise, one of team is wrong, right?
yeah.
Right.
I think it's not very not economical.
So anyway, you need to talk with the team 6.
Okay, thank you.
And then once again, you may combine those two ideas together. Underwater part can be habitat,
Mm.
above part can be a high-rise building. One structure,
Oh,
that
yeah,
can
it's,
be a very better idea.
I think very good point.
You may think about this. And then also you need to fix the size and location, then you can get the water depth first. Otherwise, you cannot get further details.
Yeah, we are still trying to decide whether to insert, so we cannot shoot yet, but we will soon decide depth, location, and the requirement for the building.
I see once again the team 6, they need some depth to make underwater structure for the population, right? So they need to have a not shallow water. Say 10-meter depth is not enough for underwater structure, right?
Yeah.
But you're also your high-rise building, you need to maybe fixed time can be better for you. All right, thank you very much.
Thank you.
Eight.
So, hello, my name is Min, and I am lead presenter of Team 8, and our team project title is Renewable Energy Sources. And this is our content. First, I'll introduce our team project background and objective for Remind. And then I'm gonna present about how we decided target application and which renewable energy technologies to use. And at last, future works will be explained. For background, since humanity uses fossil fuel for international shipping, carbon dioxide emissions from shipping gradually increases. In this trend, the carbon dioxide emissions are predicted to reach 250 compared to now at 2050. So International Maritime Organization, IMO, and worldwide agreement plans to decrease carbon dioxide emission to target amount. So renewable energy is necessary for achievement such target carbon dioxide emission level. So our objective is as following. In the past, we used only renewable energy such as wind energy, which is derived from solar energy for ship. But in present, we started to use fossil fuel and global warming gets more harsh due to carbon dioxide emission. So we are going to use renewable energy sources again to operate a ship with slogan Back to the Future. And this is our timeline. In this presentation, we are going to decide our renewable energy targets, such as location where renewable energy ship would be sailed and for what it would be applied. And then we selected renewable energy technology for modeling a ship. For our renewable ship target application, we investigated the application along the vessel categories. There are many kinds of ship application along with its weights. For most light vessel category, which is under 400 tons, they are mainly used for recreation and coastal patrol, which is for short paths. As weight gets higher, ships are getting used for carrier or container ships. And for over 50,000 tons, very large crude carrier, in short, VLCC is used. If you are trying to use renewable energy for reducing carbon dioxide emission, we thought that we should target the application that takes most part of carbon dioxide emission. Among ship types, large ships such as bulk carrier, oil tank, and container ship takes about 85% of total carbon dioxide emissions in worldwide shipping. So if we adopt renewable energy into such carrier, container ship, and then carbon dioxide emission reduction would be more effective. To select the renewable energy technology, we investigated main renewable energy technologies. First, wind energy, and second, solar energy, and lastly, biofuel energy. They have pros and cons that for wind energy, they are relatively mature technology compared to the other renewable energy. But wind is unpredictable that usable renewable energy is irregular. And for solar energy, entire solar PV technology for tourism is possible, but space for the installation of PV panels is a challenging point. And for biofuel energy, it is cost effective when used in engine, but the sources are mainly derived from feedstock that it could lead to food crisis. The table shown is the summary of renewable energy technology applications. The larger dots mean that it has more potential application in terms of economic, environmental, and social aspects. As you can see in the table, the wind energy has the most potential among the renewable energy, and also for the larger ships. And for carrier and container application, solar panel needs space that wind energy is most appropriate energy for our target application. And there are several wind energy categories such as rigid wing sail, flattened rotor, and soft sail and kite. Among these, soft sail and kite is not efficient for reducing carbon dioxide emission, but has advantage that it is easy to install. And flattened rotor is electric powered rotating cylinder and using Magnus effect for ship propulsion. And rigid wing sail is 360-degree rotating hard wing sail, and it directly leverages the wind energy that it is most efficient for reducing carbon dioxide emission. And for example, this ship named Ocean Bird achieves 90% greenhouse gases reduction. So our final decision is as following table. Our target size is large ships, and application is for carrier or container ships. It will be located at Strait of Malacca, which connects Pacific and Indian Ocean and represents 40% of global sea traffic. Lastly, renewable energy technology used will be rigid wing sail among wind energy for its high efficiency for reducing carbon dioxide level and adequacy for larger ships. For our final presentation, we are going to calculate some simple energy proportion and develop and finalize by considering costs, velocity, and size. Thrust can be calculated at like this formula, and based on cost, size, velocity, and comparison with current examples, we will develop and finalize our renewable energy source ship model. Thank you for listening.
Okay, other teams? Okay.
The presentation is very structured. I think it is very structured and the contents are well deals with many things according to the midterm presentation. So what I am wondering how you are going to calculate the energy saving ratio with your wind energy. Is there any plans for calculation? So tools you are going to use, or you're going to make a calculation with hand? Is there any plan?
We're planning to calculate on hand based on the investigation of current examples which using renewable energy, such as wind. And there's also existing current examples that using rigid wing sail, so we can easily handle it.
Thank you.
Right, can I see the previous slide where your decisions? Right, this one. Good, but one problem is the location.
Yes.
For the ship, you need to fixing the route of service, not single point. Route is a starting
route.
point, the ending point, or
Ah,
maybe
yeah.
some more port. So it
Ah,
should be a starting port, ending port, or in the middle port, depending on the route,
yes.
the service and contents of cargo should be different. Say starting from say Busan to LA, or from another one ship can be Shanghai to Paris, not Paris, Rotterdam.
Yes.
The contents can be different,
Mm,
right? The cargo should be different,
yes.
and also the requirement for the energy is different. So you need to fixing the route first,
Yes.
rather than location.
But I might choose the wrong word. Because it is routes. Because I searched the main route in
But there's say Pacific, Indian,
Yeah.
what regions? Any regions?
we have to search.
And then you are saying 83,000 vessels are passing through that Malacca Street.
예.
There is only one single point, not port,
아,
single point, right? So this is not good for ship travel. All right.
thank you.
Several comments to all of you. We have another five presentations next time on Thursday, but you need to have a team meetings, team member meetings of your colleague team members. I cannot see from today, we did not make good meetings among team members. No, I cannot see any collaboration is working. You need to have a team meeting. Also, provide answer to previous comments. I saw there are one or two teams answered to that, but the other teams did not do. So please include and submit by midnight today. Then we can grade by TA. Right? So you have a time until midnight today. You improve your presentation and then submit again by midnight. All right, see you on Thursday.
목요일에 발표하는 팀들 오늘 잠깐.
아니요. 오늘 팀만. 5 teams submission today. 5 teams presentation.